So ladies and gentlemen, you are all welcome to my YouTube channel. If this is the first time you are coming to my YouTube channel, please subscribe. So this time around, we are going to look at some solutions to some questions, which may probably actually help you in passing your first UTME as well as JAMB. So the question says, what is the concentration of a solution containing 2 grams of sodium hydroxide in 100 centimeter cube of a solution, and the molar mass of the individual element from sodium hydroxide is given in brackets, and the following options are available. So now we are going to solve the problem. So number one, we have mass. The mass is given as 2 grams. We have the mass given as 2 grams. And then we have volume. We have volume, and the volume is also given. And of course, the volume given is equal to we have 100 centimeter cube. But volume, we in this case, because based on the options, we can see that the options, they are all in dm cube. So you can just convert this volume from centimeter cube to dm cube, and to do that, it's just that we have to divide it by 1000, which is at the end we have 0.1 dm cube. That is our volume. And then the next thing now is to calculate the mole. So since what we are talking about is sodium hydroxide is our compound, and of course from the questions you can see that we have already the molar mass, and we only have one sodium here, so we are going to say 1 times 23 in bracket plus oxygen is 1, so 1 times 16, which is the mass of oxygen, then plus for the hydrogen is 1, have 1, and the molar mass of hydrogen is also 1. So we're now going to have 1 times 23, we have 23, plus 1 times 16, we have 16, plus 1 times 1, we have 1. So total now we have 40 gram per mole. So we have 40 gram per mole as the molar mass of sodium hydroxide. But to calculate mole, we are now going to say mole is equal to mass all over molar mass. And the mass is 2 grams, and the molar mass is 40. Molar mass is 40. So therefore now, if we now say 2 divided by 40, we are going to have 0.05 mole. So it means that the number of moles of sodium hydroxide is 0.05 mole. So now, which formula are we going to use? So here we have mole and we have volume. So we are now going to, and we are to calculate concentration. So I think simply we can just use this formula, which says N is equal to Cv, that is concentration times volume, is equal to mole. Concentration times volume is equal to mole. So now, the next thing that we are going to do, since we know that N is equal to Cv, so we are going to make C subject of the formula by dividing both sides by V. So this one will now cancel this. Then we now have C is equal to C is equal to N all over V, and our N is 0.05 divided by the volume, which is 0.1. And at the end we have 0.5 mole. The answer would be 0.5 mole per dm cube. It means that the answer is option B. The answer is option B. Okay. Now question 3. Which of the following properties is not peculiar to matter? It's not peculiar to matter. So A, kinetic energy of a particle increases from solid to gas. Yes, of course. Remember that in a solid particles, usually the molecules are tightly packed together. And of course, as they are changing from solid to liquid to gas, the molecules are moving far apart. And as a result of that, they have an increase in degree of freedom. So therefore, they can easily move. So therefore, generally, kinetic energy increases. It increases from kinetic energy is generally increases from solid to gas. It increases from solid to gas, because as you are moving from solid, the particles tend to move far apart. They tend to move far apart, and as a result of that, they have the degree of freedom and they can move freely. So it means that the movement increases from solid to gas. So that is why kinetic energy also increases. Then B, the random motion of the particles increases from liquid to gas. Yes, of course, because as the molecules spread far apart, it means that they can move randomly. They can move in any direction. So therefore, the order is higher in liquid than in the gas. So as a result of that, due to high entropy of the gas, they can easily move. So it means that option A and B are correct. Okay. So now, and the next option is option C. Which says the orderliness of a solid particles increases from gas to solid. So the orderliness increases from gas to liquid. No, that is the orderliness. And of course, look at option C. The random motion of a particles increases from gas to solid. So option C is correct, and option D is not correct, because the orderliness, of course, it increases because as you are move from gas to liquid, the particles tend to bring themselves together. So therefore, the orderliness increases from gas to solid, and from liquid to from gas to liquid, and from liquid to solid. So as they are moving from gas to solid from the liquid, the orderliness increases. But the random motion of your particles is also decreases. It's not increase, it's decreases. So therefore, the answer here is option E, because the random motion of your particles increases from solid to gas. No, it decreases. It generally decreases from gas to solid. It not increase. So therefore, the correct answer is D. So this is not correct. So now the next thing is question 4, which says that the principle of column chromatography is based on the ability of the constituent to A, move at different speeds in the column, dissolve in each other in a column. C, option C is to react with a solvent in the column. Then option D, react with each other in the column. So actually, when we said column chromatography is a type of chromatographic techniques that is used in the separation of molecules. And this separation of the molecules, it depends on the nature of the molecules, as well as because it's the nature of the molecules that will give us an idea of which of the base method will be applied in separating the molecules. And each of the separation techniques has its own principle. So here we are going to look at the principles of column chromatography, or the question is asking about the principle of column chromatography. So generally, the different speed of the molecules gives the particles an idea. So chromatography, we have different types of chromatographic techniques. We have affinity chromatography, we have column chromatography, we have gel gel filtration chromatography. So all these are different types of chromatography, and they're separating molecules on different principles. Like for example, gel filtration chromatography, or size exclusion chromatography. That's the other way we call it size exclusion chromatography. Size exclusion chromatography is separating molecules based on their different sizes. And we have affinity chromatography, that is based on binding, based on affinity. And then we also have column chromatography. And the column chromatography, the principle behind column chromatography is based on the movement of the separating molecules on different speeds. So it's based on the movement of the particles at different speed in the column. So it means that option A is the answer here. So then the next thing now that we are going to look at is the next question, which is question 5. So question 5 here says, okay, it is a graph. So we have a graph, and the graph here is a graph. So this is the graph. So we have a graph is drawn as VB against, that is pressure times volume against P. So now let's look at what the question says. From the above, an ideal can be represented by. So when you said ideal, it means that a situation where there is no any deviation is a situation where there is no any deviation. So it means that here we have different gases. We have gas K, L, M, and N. So if you can see that gas A, let me start with gas K. So the gas K here, if you can look at the gas K here, so it started from here, but it's deviated. And this one also from here is moved to this direction. and this one also moved to this. So if you look at it, you can see that it is only N that moved straight without any deviation, without increasing or decreasing. So it means that the ideal situation is the gas N. The ideal situation is gas N. That is, it means that it follows a formula. It follows the formula that says PV is equal to, it follows a formula that says PV is equal to nRT. So it means that there is no deviation. So it means that the answer to this question is, the option is the option that carries N. So it means that option B is the answer. Option B, this is option B. So option B is the answer to this question. So then the next thing now is question 6. Which of the following question is correct about periodic table? The non-metallic properties of the element tend to decrease across the period. The non-metallic properties of the non-metallic properties of the element tend to decrease across the period. No. So this one is not correct, because remember in the periodic table, if we have, let's say this is just a sketch of the periodic table of an element. So you know that generally the elements that are found on the left here are metal, while the one that are found at the from right to left. So the element that are usually found at this side, like group 1 here, group 2, they are metal, and we have group 3. So generally group 1 and 2 are metal, and as the element, or as it moves from the metal, that is from metal, that is from group 1 to group 8, from group 1 to group 8 across the period, it means that the non-metallic properties increases, it's not decreasing, because group 1 is more metallic than group 2, and group 2 is more metallic than group 3, and group 3 is more metallic than group 4. So therefore, it means that group 2 is more non-metallic than group 1 and group 3. So therefore, generally, the non-metallic properties of the element is increasing from group 1 to group 8. So therefore, option A is not correct. So then the next thing is option B. The valence electrons of the element increases progressively across the period. So the valence electrons of the element increases progressively across the period. Yes, this option B is correct, because the reason is group 1 element have only 1 electron on the outermost shell, while group 2 have only 2 electrons on the outermost shell. Group 3 have 3 electrons. So it means that as you move progressively across the period, the number of electrons on the outermost shells are increasing. So option B is correct. So let us also look at option C. Let's also look at option C. So option C says element in the same group have the same number of electron shells. No. Element in the same group have the same number of valence electrons, not shell. So this describes the period. This describes the period of the element. And option D, element in the same period have the same number of valence electrons. This option D is also not correct. This describes group. So it means that option B is the correct answer. So now we are moving to okay, so then the next question is, okay, we are now moving to question 7. So question 7, let's look at what we have in question 7. So question 7 says the relative atomic mass of a lithium of 90% Li and 10% Li. So it means that we have lithium with a lithium with 95% abundance and 10% abundance. So here we want to get the relative atomic mass of a lithium, and the following is our option. We have 6.9, we have 7.1, and then we have 6.2, and then we have 6.8. So how do you do this calculation? So actually, we can't just calculate the relative atomic mass of lithium without knowing the mass number of lithium. But in normal sense, like this lithium is supposed to have an isotopes. but there are some non-isotopes of lithium. Let me just make some this, so that at least even if it's just for we or for you to get an idea of how to do the calculation of the relative atomic mass of an element when the isotopes of two different elements is given. So assuming now is an assumption because it's not given in the questions. Here it is there. Here there must be like atomic mass of a lithium. So let's say the isotope of lithium here is 6 here, and the isotope here of lithium is 7. So how are we going to calculate the relative atomic mass? It's simple to calculate the relative atomic mass. So to calculate the relative atomic mass of lithium, what we are going to do is, this one is 6. We are now going to say 6 times 90 divided by 100, then plus the other one is 7. So 7 times 10. I'm going to say 7 times 10 divided by 100. So if you can do that, then you can get the answer. So now how are we going to get the answer? So we are now going to say 6 times 90. If you first your calculator, when you multiply 6 times 90 divided by 100, we have 5.4. And when we multiply 7 times 10 divided by 100, we are going to get 0.7. So it means that if we add this thing, if we add them, we have 7 points. Sorry, we are going to have 6.1. So this is how to do the calculation. So, but I'm not sure because the mass number of the two lithium here is not given, but that is how to do the calculation. So I'll just give you this so that to give you an idea of how to do the calculation. So like, for example, so we are moving to question 8. An isotope has an atomic number of 16 and a mass number of 13. Then the number of protons it contained is, so it means that this is an element which have an atomic number of 15 and a mass number of 31. So the number of protons it contains is, so remember, an element with the atomic number of an element reflects the number of protons. So if atomic number is 15, it means that the number of protons is also 15. So the number of protons here is 15 because this is an element. Let's say the element here, let's represent the element as X. So it means that the mass number is 31 and the atomic number is 15. So since it is proton, the number of proton is going to be 15 since the atomic number is 15, and the electron number is also 15 since it is neutral. So if the element is neutral, it means that the number of protons and electrons are the same. And of course, to calculate the number of neutrons, you are just going to say 31 minus 15. That is the mass number minus proton number. Then you are going to get the number of neutrons. So the molecular lattice of iodine is held together by a electric bond. Okay, so ladies and gentlemen, we are going to stop here. So let's meet in the next video. We are going to meet in the next video.